Welcome to this lesson on decibels. Decibels are the standard unit we use to measure sound intensity. Throughout this video, we'll explore how the decibel scale works and why it's so important in understanding sound measurement. So, what exactly is a decibel? The decibel, abbreviated as dB, is a unit of measurement that expresses the ratio of two values on a logarithmic scale. In sound measurement, we use decibels to compare sound intensity relative to a reference level. This makes it much easier to work with the enormous range of sound intensities we encounter in everyday life. You might wonder, why do we use a logarithmic scale for sound? The answer lies in how humans perceive sound. Human hearing perceives sound logarithmically, not linearly. This means we don't hear twice the intensity as twice as loud. The logarithmic scale compresses the enormous range of sound intensities we can detect. This range spans 6 orders of magnitude, from the quietest whisper to the loudest sounds we can tolerate. Here's the fundamental formula for calculating decibels. Beta, measured in decibels, equals 10 times the logarithm base 10 of I divided by I0. In this formula, I represents the sound intensity we're measuring, and I0 is the reference intensity. This logarithmic relationship is what gives the decibel scale its unique properties. The reference intensity, I0, is set at 10 to the power of negative 12 watts per square meter. This value represents the threshold of human hearing at 1000 Hz, which is the frequency where our ears are most sensitive. This reference point corresponds to 0 decibels, the quietest sound an average human can perceive under ideal conditions. The decibel scale has some fascinating properties. First, multiplication of intensities becomes addition on the decibel scale, which simplifies many calculations. Second, every 10 decibel increase represents a sound that is 10 times more intense. And third, every 3 decibel increase approximately doubles the intensity. These relationships make the decibel scale incredibly useful for comparing sounds of vastly different intensities. Let's look at some everyday examples. A whisper measures around 30 decibels. Normal conversation is about 60 decibels. City traffic typically reaches 80 decibels, and a rock concert can hit 110 decibels or higher. Notice how these familiar sounds span a wide range on the decibel scale, yet the numbers remain manageable and easy to compare. Let's work through a calculation. If a sound has an intensity of 10 to the power of negative 6 watts per square meter, what is its decibel level? Using our formula, beta equals 10 times the logarithm base 10 of 10 to the negative 6 divided by 10 to the negative 12. This simplifies to 10 times the logarithm of 10 to the 6th power, which equals 10 times 6. The answer is 60 decibels, which corresponds to the level of normal conversation. Understanding decibels is crucial for protecting our hearing. Sounds at or below 70 decibels are generally safe for prolonged exposure. However, sounds at 85 decibels and above can cause hearing damage over time, especially with extended exposure. Sounds at 120 decibels and higher cause immediate pain and can result in permanent hearing damage. Always protect your ears when exposed to loud environments. Let's review the key points. Decibels measure sound on a logarithmic scale that matches how humans perceive loudness. The formula is beta equals 10 times the logarithm base 10 of I divided by I0. Every 10 decibel increase represents a 10 times change in intensity. And finally, remember to protect your hearing when sound levels exceed 85 decibels. Understanding decibels helps us measure, compare, and safely manage the sounds around us.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.